Today we're going to be solving quadratics using a method that is not factoring, but it's also a method that only works in certain cases. The method we're going to use is what's called the square root property. It only works if we can get x squared, if our equation looks like, or we can make it look like x squared or whatever your variable is, squared equals number. In these cases, the square root method is actually a lot easier than factoring. It's nice and quick. It just only works if we can get it in this format. So, the first few we're going to look at are already looking like that. It's variable squared equals number. Just like solving any other equation, we want to undo whatever's happening to the variable. So to undo the squared, we do the opposite of squaring something, which is take the square root. And just like when you've solved other equations in the past, anything you do to one side, you've got to do to the other. On this side, square root and squared cancel each other out. They're opposites or inverse operations, so I get just b. On the other side, the square root of 64 is actually two numbers. Remember, square root is number times itself is what gives you the number you're looking for. And so the square root of 64 can either be 8 or it can be negative 8, because 8 times 8 is 64 and negative 8 times negative 8 is 64. So you have two solutions here, positive 8 and negative 8. And in math, if you haven't seen this before, we have a shortcut for that. Instead of writing positive 8 and negative 8, we write plus or minus 8, which stands for positive 8 and negative 8. This is how I tend to write my solutions for these. If you'd rather list them separately, you can, and that works too. So if it's just variable squared, take the square root of both sides, you'll get two solutions, plus and minus whatever the square root of that number is. Let's try another one. So this next one, we have a squared equals 41. To get a by itself, I'm going to take the square root of both sides. 41 is not a perfect square. So you can write your answer two different ways here. You can just leave it as plus and minus the square root of 41. If you're planning on going to college someday, that's how professors tend to like to write things that's more exact. Or you can write it in the decimal form. If you do square root of 41 in a calculator or Desmos, you will get a decimal, and that decimal is 6.4. So the other way you could write your answer is plus or minus 6.4. I am fine with either way. They mean the same thing. So if you want to leave it as a radical, cool. If you want to write it as a decimal, also cool. Next up, we have p squared equals 33. To undo that squared, we take the square root. So this side becomes just p. Once again, 33 is not a perfect square. I don't get an integer when I take the square root. So you can either write your answer as plus and minus square root of 33, or if you'd rather like to use a decimal, again, use a calculator, use Desmos. Most people don't know these crazy decimals off the top of their head, and you can round to one or two decimal places. You get 5.74 when you do that, and once again, plus or minus. So you either write it as plus or minus square root of 33, or plus and minus 5.74. Moving on from here, we can have equations that look a little more complicated than just something squared equals number, but as long as we can rearrange it or convert it into something squared equals number, we can still use the square root property. Typically speaking, taking the square root is kind of the last step in the process for these. So, to get r squared by itself, the first thing I need to undo is this minus 3. To undo minus 3, I add 3 to both sides, just like you're used to. So I get r squared equals 4. I still need to undo the square root. So to do that, or to undo the exponent too, so I do the square root of both sides. And I get r equals, the square root of 4 is 2, so r equals plus or minus 2. Easy peasy. These next two, same idea. You're going to solve the usual steps you take to solve an equation. So we're going to start by undoing the addition or subtraction, then dividing, then doing our square root. So let's try it. Undo plus 10 by subtracting 10. 59 minus 10 is 49. Undo the 100 in front, that means 100 times, by dividing by 100. So I get a squared equals, I'm going to just leave it as a fraction, 49 over 100. And then to take the square root here, you can take the square root of a fraction, that's no big deal. The square root of a fraction is the same as the square root of the top over the square root of the bottom. The square root of 49 is 7. the square root of 100 is 10, and it would be plus and minus because we could either have positive 7 over 10 or negative 7 over 10. So my solution here would be A equals plus or minus 7 over 10, or if you like decimals, you could say A equals plus or minus 0.7. They mean the same thing. Next up, very similar, start by adding 5 to both sides. We get 8n squared equals 264. And then divide by the number in front of n. And when you do that, you get 33. Feel free to use a calculator. I did when I worked on this problem. Now, we need to get n completely by itself, so we're going to take the square root. And we actually already looked at this earlier, so I'm not going to make myself do extra work. We already know that 33 is not a perfect square, so my answer is either plus and minus square root of 33, or you can write it as plus and minus the decimal version, which is 5.74. Either of those is fine. I want to show you two more that look slightly differently. I'm just going to erase these ones, keep these ones up so I can show you the slight difference. But the concept is the same. Let me get those written up here so you can see them too. Okay, so these look a little bit different, but notice the format is still the same idea here. I have something squared equals number. Because everything inside the parentheses is being squared here, in order to do anything to solve this equation, I need to undo the squared first. So instead of waiting to do the square root till kind of the middle to end of the problem, I'm going to do it at the beginning because I need to get everything on the left-hand side out of the square root. So I'm going to start here by taking the square root of both sides. The square root and the square cancel each other out, so I'm just left with x plus 3 here. Square root of 25 is plus and minus 5. You're not done because you want x completely by itself. This actually stands for two different equations. X plus 3 equals positive 5, and x plus 3 equals negative 5. For me to solve this, to remember to do both things and to get all my signs and everything right, I like to write it out as two separate equations. If you're comfortable doing this in your head and if you want to jump from here to the answer, that's fine without showing this work. But for me, I mess up signs really badly if I don't split it into two equations. Okay. So let's solve these both. To get x by itself, I need to subtract 3. 5 minus 3 is 2. And my other solution is negative 8. Notice now that my answer isn't plus and minus the same number because I had to subtract 3 to two different numbers. So that's why your answers are going to look a little bit differently here. All right, last one. Looks very similar to the one we just did. Everything is being squared on this side, so I undo that by taking a square root. Cancel, cancel. I get x minus 4 equals square root of 49 is 7, so plus and minus 7. This really stands for x minus 4 equals positive 7, and x minus 4 equals negative 7. And then I'm going to solve both of those equations. 7 plus 4 is 11. And then negative 7 plus 4 is negative 3. So that is the square root property. This will help us get ready to solve a little bit more complicated equations. Square root property is really nice when you have an equation that looks like this, much faster than factoring, much easier to deal with. Just only downside is it only works when we can get our equations to look like this. That's it for today. Have a fantastic day.